All right, hi, this is Dr. Matthew J. Traum from Engineer Inc. The purpose of this video is to demonstrate a working prototype of a new commercial product that I've been working on and finally got to work. This is a hydraulic jump generator, and I'm going to show you the hydraulic jump first, and then show you the rest of the apparatus that creates it second. So what you're looking at now is that jump. It's just produced by a steady stream of water, and there's a couple of things that we're interested in measuring for a hydraulic jump. This one is pretty stable, so it should be pretty easy to measure. So the first thing that we're interested in is the diameter of the jump, and so the way that I'm going to get the diameter is I'm going to just estimate it. I'm not looking for perfection, but just something close. So I'm just going to come in with my dial caliper and try to move the caliper such that it approximates the diameter. So that's how I get that measurement. And then we're interested in the height both before and after the jump. And if we know those pieces of information and a mass or volume flow rate, we can essentially solve mass conservation and momentum conservation simultaneously to compare this jump to the theory. So the way that I get the elevations is I just come in with a little wooden dowel. This happens to be a matchstick, and I just tap, boop, and hard to see on video, but the matchstick itself gets wet, and you can measure the section of the matchstick that's wet, and that tells you the elevation of the water before the jump. And then I can just take the same matchstick and stick it in the water after the jump, and again measure its height, and so that gives me the height before the jump and after the jump. So now that we've seen this relatively stable hydraulic jump and how to get the height before the jump, after the jump, and the diameter of the jump, let me show you the rest of the apparatus that was used to create it. So let me grab the camera here, move my mount out of the way. Okay, so if we back up, we can see that the jump, there we are in focus. The jump is created by an adjustable valve. So I can make the jump bigger or smaller by adjusting the flow rate of the water through that valve. And zooming out even further, the valve is attached to a graduated cylinder. So there's a graduated cylinder with water being fed in at the top. And the way that the water is fed in, this is a continuous loop. I've got a bulkhead fitting here that pulls water out of the container where it's accumulating after it goes through the hydraulic jump. It goes through a pump. The pump moves the water into a flow meter. This, by the way, is a power meter that is telling me how much power the pump is consuming. So if I'm interested in calculating pump power for a particular volume flow rate, I can do that there. Here is my rotameter, which is giving me a volume flow rate, so I can measure it in gallons per minute, for example. So if I get right in line here and focus in, it looks like I'm right at 0.2 gallons per minute. And then the water runs through this pipe and back up to the top of the graduated cylinder, where the water level is maintained to facilitate the continuous steady state hydraulic jump. So the things that I can adjust here, I can again change the valve setting that can either increase or decrease the diameter or the radius of the jump, and then I can use a speed controller right here to adjust the rate of the pump to match the rate of the fluid coming out of this valve. And I know that I've got the pump matched to the volume flow rate coming out of the valve by looking at the water level there on the graduated cylinder and seeing that the water level is fixed. If the pump runs too fast or too slow, this water level will increase if the pump is going too fast or decrease if the water is going too slow. So anyway, that is the end of this Engineering Inc. video. Please check back in the near future for more videos that demonstrate new commercial products being created by our company for mechanical engineering education laboratories for remote online learners. Thanks for watching. See you next time. Bye.